Good afternoon, students. Am I audible? So we are going to solve a few numericals related to our specific energy. Okay. So you kindly write down the first numerical. So you write down the first numerical, 3.1. So write down the question. Okay. What is given? We have to find an expression for YC. YC is nothing but your critical depth. Okay. Is related to alternate depth. If you remember, alternate depth are depths which have equal specific energy. If you consider the graph for a particular discharge, your specific energy in this pattern. So if you consider any specific energy, you'll be having two depth. Okay, one is in supercritical and one is in subcritical. These two depths are alternate depth. That is your y1 and y2. Okay, so alternate depth are depth which have same specific energy. Okay, so you write down this expression. We have to prove that YC for a rectangular channel is this. Okay, that is your YC is equal to twice y1 square y2 square divided by y1 plus y2 to the power 1 by 3. Okay, we have to show that. So you write down the question. Over. Okay, so we proceed to the solution. Okay, okay. So we all know for alternate depth our energy is same. Okay, so definitely if you see the specific energy equation, if you remember, we will be having only two components. One is y plus your kinetic energy v square divided by twice z. Okay, v square by twice z. Okay, so for alternate depth we have y1 and y2. Okay, so for both the depth your specific energy is same. So that is why we can write E1 is equal to E2. Okay, both the specific energy is same. Okay, in one condition we have used one depth and in another condition is the second depth. Okay, because we all know that for alternate depth your specific energy is same. So that is why y1 plus v1 square by twice z is equal to y2 plus v square by v square to v2 square divided by twice z. Okay, you write down this expression. then what we are going to do, we replace this velocity. Okay, velocity we all know v is equal to q by a. Okay, so area is nothing but, as it's given in the question, it's a rectangular channel, so in the place of area we can write b multiplied by y. So for if you consider that first case, so it will be y1, and if you consider this, then it will be y2. Okay, so that is why we are replacing this velocity divided by q by a, as this velocity is square, so that is why you'll be having q square divided by a square. Okay, so in both case you replace velocity by q by area. Then you write this expression. So that is why if you see here, y1 will be same, then plus 1 by twice z. In place of v, we have written q square by a square. In place of a square, you can write b square multiplied by y square. That is why q square by b square multiplied by 1 by y1 square. Okay. So as here we have considered that alternate depth 1, so that is why we have written y1 here. So it will be same here, but that depth will be changed. Okay. Then we all know small q, this is nothing but discharge per unit width of the channel. So that is why we have separated that q by b. Okay, so that we got this small q. Okay, so that is why y1 will be left as it is, plus q square by b square, it will be small q square divided by g, and 1 by twice you have 2, so twice y1 square, and the second part is also same. Okay, so you write down the steps till here. Okay, again this thing we are going to replace by critical depth. This thing we have already discussed. For rectangular channel, your critical depth is yc cube is q square by z, or you can say yc is equal to yc is equal to q square divided by z to the power 1 by 3. This derivation we have already discussed. Okay, over. Okay, then so we are multiplying both the side by twice y1 square y2 square. Okay, so see here we have y1, then if you multiply by this, then it will be twice y1 cube, because you have y1 square here and you have y1 here. If you multiply, it will be y1 cube y2 square plus. Okay, if you multiply by this, 2 will be cancelled out, y1 square will be cancelled out. What will be left out is y2 square yc cube. Okay, is equal to, again if you multiply by twice y1 square y2 square here with y2, it will be your twice y1 square y2 cube. Okay, plus, again if you multiply by this with this term, it will be your 2 will be cancelled out, y2 square will be cancelled out, it will be left out with y1 square yc square yc cube. Okay, okay, then this is your simple mathematics. Okay, thus you have to bring a yc value in this form. Okay, you simply follow the steps. Okay, very simple. Kindly just note it down these steps. Okay, till here. over. Okay. So we move on to the next numerical. Okay. The second numerical is this. Okay. What is given? A rectangular channel of 3 meter wide. That is, the width of the channel is given 3 meter. Okay. Carries a discharge of 10 meter cube per second. So discharge is also given 10 meter cube per second. Okay. Specific energy is given here. Okay. Specific energy. Specific energy is given as 2 meter. Okay. Calculate the alternate depth and corresponding Froude number. So we have to find out the y1 and y2 for that particular specific energy, because we all know for a specific energy we will be having two depth, and those two depth are called alternate depth. One is in supercritical and one is in subcritical flow. Okay, so we have to find out those two depth in this numerical, and then we have to find out the Froude number. Okay? So first you consider that energy equation, that is your specific energy equation, y plus v square by twice g. So that velocity you can replace by q by a. Okay? That velocity you replace by q by a. So as it is v square, so it will be q square by a square. Okay. Then that area you replace by v into y. That is why, because area square is there, so b square multiplied by y square. As it is a rectangular channel, it is given in the question. Okay. So we all know that the energy is given 2 meter in the question. So in place of energy, we have substituted 2. Okay. So y plus this equation, q square divided by twice g, b square multiplied by y square. Okay. So discharge is also given 10 meter cube per second, twice multiplied by 9.81. That is your acceleration due to gravity, multiplied by width of the channel is also given 3 meter. So that is why it's 3 square multiplied by y square. Okay. So you will be having one expression and one unknown. That is y. Okay. Solve this using your new calculator and find out the y value. You have one equations, you have only one unknowns. Okay. So you can easily find out solving this equation. Okay. So use your calculator and find out the y value. You'll be getting one is 1.84 and another one is 0.64. Okay. Kindly use your calculator and solve that equation and see you are getting the same value or not. Done. Over. Okay, I got disconnected. Okay, so okay, fine. Then you have to find out the fraud number. Okay, for suppose for your depth 1.84, because see, by looking the depth of flow you can say which one will be in supercritical and which one is subcritical, because this is the graph. If you remember, for a particular discharge you will be having a specific energy curve. Okay, so for your specific energy 2 meter that is given, we will be having two depth. Okay, so this is will be your critical depth. If you draw a straight line here, it divides the whole graph into two sections. One is your supercritical and one is your, this is your subcritical. Okay, and if you remember, for supercritical your Froude number is greater than 1, and your subcritical flow your Froude number is less than 1. Okay, so you will see that smaller depth is always in supercritical flow. So this 0.64 is in supercritical flow condition. Okay, so that means the Froude number for this is always greater than 1. Okay, and that higher depth, if you see this higher depth, it will be in a subcritical flow where your Froude number is less than 1. Okay, so you find out the Froude number by, I think you all know that equation. We have already discussed many times about the Froude number. Froude number is equal to V by root over GD. Okay, G and D. D is nothing but A by top width. Okay, area by top width. So for rectangular channel you can directly write Y. Okay, so in place of Y you are going to substitute 1.84 and see your FR2, that is your 1.84, your it is in subcritical and should be less than 1, and we are getting that Froude number is less than 1. Okay, and similarly you have to find out the Froude number for that 0.64 depth. Okay, that also you find out and see if you are getting greater than 1 or not. Okay, so I'm going to end this meeting here, and we are going to connect again after 5 minutes. Okay, for the next class. Okay, so you just find out this two Froude number, and if you have any doubts, then we will discuss in the next class after 5 minutes. Okay, thank you, students.